Hello everyone, our team will be presenting our project on predicting no-budget match performance using real ATP data and machine learning methods. We feel like he has one of the most consistent careers in tennis history, which makes him an excellent subject for data analysis and predictive modeling. And to begin, I will go through a quick overview for our dataset. We use the ATP Man single dataset, which contains match data from 2005 to 2024. This dataset includes many different data, which includes match outcomes, service types, tournament levels, player names, and even their ranking in that specific year. And from this large data set, I created a subset by selecting all matches where he appeared as either the winner or the loser. And for the code, you can see on the top, here is on the top left, here is our data from the matches begin with 2005 till 2024. And here you can see the Python code where we construct the dataset. In this section of the code, I filter matches containing digital coverage, created new variables such as ranking difference, and clean the categorical features like surface and tournament level. And this was the foundation of model training. So look at the summary statistics of this data across this 20 years. He has played 1,035 and 355 matches from, and overall he had a winning probability with nearly 84%. This high baseline masters because a player who wins frequently already creates a natural bias of the prediction model. And back to the slide. So when I train it first as the logistic regression as my first model, the accuracy which nearly 87%. This is extremely close to its real winning probability, show that the model is learning meaningful patterns. And to better understand why the model behaves this way, we need to look deeper into tennis surveys. So next. On hard courts, he plays the most matches and performs very consistently. Hard courts are medium pace, predictable surface, and this lead to a logistic regression accuracy of 87%. On clay courts, the slower surface and higher bounce cause more variability. Although he is still strong, clay matches are more unpredictable, so accuracy drops to nearly 80%. On grass court, he is extremely dominant, especially so the model achieves the highest accuracy of around 92%. And this result aligned closely with real-world tennis behavior and confirmed that the model's predictions are not random but grounded in performance patterns. And after analyzing surveys using logistic regression, I want to see whether a more complex model would behave differently. So I use a second model, which is random forest. So this part of the code has shown my random forest pipeline. Random forest often captures nonlinear interaction between, especially with categorical features like surface and tournament level. After training the model, I evaluated its performance by tournament levels. So Here is the random forest accuracy by tournament level. The result again reflected his entire career patterns very well in Grand Slams, where he has historically been extremely dominant. Accuracy is the highest with 88.888. In the Davis Cup, the accuracy is 87 percent, showing consistent performance in national team events. And Master 1000 tournaments, which are highly competitive, it show an accuracy of 83%. And ATP 250 and 500 events show an accuracy of 0.8%, 0.8 due to mixed competitiveness. And the ATP finals, however, show a very low accuracy because there's like only 8 players that can join this event through the entire ATP event. So this is because the so it's making it very match extremely difficult to predict. So because sometimes he might not join the top 8. So and for the Olympics, the accuracy is 0.8, influenced by the limited number of matches. Once again, the machine learning results match really close to the competitive environment, very closely to its real data in the real world data. So both a real logistic regression and random forest have achieved strong performance because his real world performance is extremely consistent. Surface type significantly affects predictable. Grass and hard courts are more stable, while clay introduce more variability. And tournament levels also influence the difficulty of prediction. Grand Slam and Davis Cup matches are easier to predict due to his dominance, while ATP finals are much harder because the competition is tougher.
Hi, my name is Corrine, and I will continue on the part 2 on our project. This slide introduced the logistic regression model used to predict whether Djokovic wins the match when he versus Big Three, which is Federer, Nadal, and Murray. Since many features are categorical, like surface, tournament level, and opponent, we applied one-hot encoding to convert each category into binary variables. This allows the model to learn the impact of each specific factor, such as different surface or individual opponents. The main input used in the model were ring gap, surface type, tournament level, and opponent. For data preparation, we filter for matches where Djokovic was one of the players and labeled the results as 1 for win and 0 for loss. We compute ranking-based fixtures, including Djokovic's ranking, his opponent's ranking, and the ring gap. We removed any rows with missing ranking data to maintain consistency. And finally, we select the core variables for modeling: surface, treatment level, ring gap, and opponent. This is a code that I filter the dataset to keep only matches where Djokovic is either the winner or the loser. This gives us a focused dataset containing only Djokovic's match history. And for block 2, I create the opponent column by identifying the other players in each match. I also generate the result variable labeling Djokovic win as 1 and losses as 0. For this block, I extract Djokovic's ranking and his opponent's ranking, then calculates the rank gap between them. I also select the features for modeling and apply one-hot encoding to convert categorical fields into numeric variables. And I checked for missing values in the feature set. We removed 4 rows with missing rank gap to ensure cleaning training data, and splits the data into training and testing sets and fits the logistic regression model. The final test accuracy is then computed to evaluate the model performance. We compare Djokovic predict and actual win rates against Federer, Nadal, and Murray. Predicts values closely match historical results, showing the model captures key matchups patterns. Federer and Nadal predictions align well with actual data, while Murray shows Djokovic's strongest predict advantage. Overall, the model performs reliably against the big three. This chart shows that predict and actual win rates of Djokovic against big three. The predictions are very close to the real outcomes, showing strong model accuracy. This confirms that the features like rank gap, surveys, tournament level effectively explain match results. And for the code, these 2 blocks are the codes that show how we calculate Djokovic predict and actual win rates against Federer, Nadal, and Murray. And this block is how we generate a bar chart comparing the predict and actual win rates. It plays 2 values side by side for each opponent so we can visually assess how well the model matches in real performance. We highlight opponents with the highest prediction errors. These players are hard for a model to predict because either they are rare opponents or have unusual match outcomes. These are the patterns that ranking alone can explain. It shows where a simple model reached their limitations. This is a code that compares the model prediction with the true outcomes, compute, and error rate for each opponent. And by grouping the result by opponent, we identify which players the model struggle with the most. This selects 10 opponents with the highest prediction error rates and plots them into a bar chart. The visualization clearly shows which player caused the largest mismatch between predict and actual results. This heat match shows how Djokovic win rates against big three vary by surface. Surface is a major difference. Nadal dominates on clay, while Djokovic performs strongest on grass against Federer on hard court overall. This confirms why surface is an essential features for in the model. This part of the code calculates Djokovic's win rate against each of the big three across the 3 playing surface, which is hard, clay, and grass. We loop through each opponent's surface and combinations and compute the average match result for the subset. And for the last part of the code, it visualized the win rates using a heat map, just which is the chart shows on the slides before.
Hi, I'm Teresa, and I'll continue with the third part of our presentation where we focus on Djokovic's performance in deciding sets, which is the moment when everything comes down to one final set. So for the first page, to begin, our data set includes 20 ATP match files from 2005 to 2024 with a total of 58,502 matches. And after isolating only Djokovic's matches, we end up with 1358 rows, which essentially captures his full ATP career. And to prepare the data for analysis, we engineer several key fields: the opponent identity, a binary win-loss variable, the ranking gap between Djokovic and his opponent, the number of sets played, and a decider indicator that tells us whether the match went to a final set. We also extract the match era so we can study how his performance changes over time, and these engineered features give us the analytical foundation to evaluate Djokovic across different surfaces, tournament levels, opponent strength, and pressure conditions. And for the next page, when we compare matches with and without a deciding set, the win rate is 86.9 and 72.6%. And this shows that he often finishes matches early, but once the match reaches the final set, the competition tightens. And let's take a look of the code. And this cell calculates these win rates and generates the bar chart on this slide. And next, we look at deciding sets by surface, which is the hard course win rate is 0.75, the grass surface is 0.73, and the clay surface is 0.68. And these numbers match Djokovic's career pattern. The hard and grass are his most consistent environments under pressure, while clay introduces more variability. And let's go back to the page 3. And this page highlights two broader trends. First, deciding sets become more common in later rounds where Djokovic faces tougher competition. Second, the heat map shows how much difficulty varies across his career during peak seasons like 2011 and 2015. The likelihood of Djokovic entering deciding set drops noticeably, consistent with the periods where he was especially dominant. So let's take a look of the two charts, which is cell 21. That is, the cell produces the round-based deciding set probabilities. So we can know that even though he sometimes feel tough when uh, playing the deciding set, his win rate is still over 50%. Then the cell 22 is about to create the ear-by surface heat map. And for the carpet surface, it is because most of the game they had canceled the carpet surface, so the data is still 2005 and 2006. Then let's go back to the page 4 of the presentation. It is to estimate Djokovic's probability of winning a deciding set, and we train a logistic regression model using features such as the surface, round, tournament level, ranking gap, opponent identity, and ear. The model reaches about 72 accuracy, which is strong given the complexity of sports outcomes. The box and swarm plot on the slide shows predicted winning probability by surface. Hard and grass again appear the most stable, while clay shows the more variation. And let's take a look of the plot or the chart that I mentioned is um this one is where we build and fit the logistic regression model. And this one, cell 20, is the cell generates the predicted probability visualization by surface. And and there are some additional findings from The code part, it is the cell 23. The bubble plot is the rank gap versus the predicted probability. And this bubble plot shows how predicted winning probability changes with the ranking gap. And matches with strong opponents shift the probability downward, and longer matches tend to appear in higher rounds. So let's get back to the conclusion, which is across 1358 career matches, Djokovic shows exceptional dominance, especially in matches that do not reach a deciding set. When matches do extend to a final set, the competition tightens, and factors such as surface, opponent strength, and tournament round play a major role. Our logistic regression model captures these patterns with strong accuracy, reinforcing Djokovic's reputation as one of the most resilient players in tennis history.